So we've known since I think the early 19s by Dukowski and Sheff, as well as Terry et al., that synapses are being lost in Alzheimer's disease. Others have shown this as well. But this was in human tissue, and these people looked with a lot of detail, and they found that synapses were not only being lost in Alzheimer's disease, so there was fewer of them, but also this synapse loss correlated best with the cognitive decline that happens in Alzheimer's disease. And this is very important because you've got many different types of pathologies and different outcomes that you can measure. So things like neuron loss as well, or different pathologies like amyloid and tau. And out of all of these different correlations that they run, both of them found that it's the synapse loss that correlated best to the cognitive decline. And so we've known this since then, and others have shown this very well in many different mouse models as well of Alzheimer's disease. So that has translated very well from mouse to human. And we are trying to understand now better what is going wrong with the synapses or other cell types that are inducing the synapse loss. So there's two different hypotheses that you could break this up, if you will. You could either say that the synapse itself is changing the way it's structured, or there are different signals on the synapse that are telling other cells that, hey, it should be eliminated, or the synapses themselves by intrinsic mechanisms are degenerating. So for the glial cells specifically, we've known from the development aspect of things, particularly in mice, that immune systems and new cells of the brain, like microglia and astrocytes, can recognize weaker synapses and remove them. And this is part of the physiological aspect of eliminating synapses and helping with synaptic pruning, so getting rid of the excessive synapses that we have in the brain. However, in Alzheimer's disease, it is expected that some similar mechanisms may be aberrantly reactivated. So using some of the similar mechanisms like the complement system that has been very well characterized to deposit the signals on the synapses and not only remove degenerating synapses that should be cleared away, but also healthy synapses. And the reason we think that also healthy ones are being targeted is that because a few groups recently have shown that when you block this increased elimination of synapses by microglia specifically, then you also have a rescuing of synaptic dysfunction, but also rescuing of some of the cognitive deficits that these mice show. And therefore, we think it's not only clearing of dead synapses that are being removed intrinsically, it's also that these glial cells play a role in this. However, most of what we know is in mice, and not so much has been done in human, and this is part of where my work has started.